So, first we will start Ansys Workbench. Here we will head on to the ACT start page. I assume that you have installed the Ansys Moving Heat Source extension. If not, I have provided links on how to install it in the description below. From here we will select the moving heat and enable the extension. Now let's come back to the project page. Here select transient thermal and drag it into the workspace. Now we will go to engineering data, right click on it and select edit. So here structural steel is the default material. We will go to engineering data sources and general materials. Here we have to find stainless steel. So we got here, right click on stainless steel and select add to engineering data. So stainless steel has been added to our project, as we can see over here. We can edit the properties of stainless steel from here. Now we will go back to the project page. Let's import the geometry. Right click on geometry and select import geometry and browse. So this is our model in the .igS format. We will open it. Now right click on geometry once again and select edit geometry in space claim. So here we have our geometry over here in space claim. Now we have to add some lines to it for the moving heat source. These lines will act as path for the moving heat source. We will go to sketch mode and select the top face. Now we will go to plan view. Now from the ribbon icon, select the line option. We will draw line from the midpoint. Now we will go to the offset option. Select the offset curve and then select the line. Move your mouse towards the left. We are getting this one, the distance of offset. We have to select it as 0.05 as it is 50 microns. We have to repeat this process as shown. There must be some other way to do it faster, but I do not know it in space claim. Here I am increasing the speed of the video 4 times because this is a tedious and repetitive process. For now I am drawing only these many lines. You can continue this towards the end of the model. Now we will go to the 3D mode. Then click on split. Now we have multiple surfaces. As you can see, the top surface has been divided into multiple parts. Now we will exit space claim. Now right click on the model and select update. So this is our model. As you can see, we have different surfaces over here. But we are not going to use this model. I will tell you the reason later. Now I am using NX. Now I am going to use NX to get the lines on the surface. You can use your CAD software for this. Here we are creating a new project. Now we have to import the IGS file. Here we have to provide the path of the IGS file that we wish to import. So this is our file. Then we will click on OK. So our file is now imported. Let's zoom in into the file. So this is our model. Let me change it to wireframe. Okay, so now we can see the model with the defects in it. Now we'll go to curve and sketch in task environment. I am selecting the top face as we did for the space scaling one. Now here I will select line and draw lines on this model. I am selecting approximately the midpoint over here and drawing a line. Now I will offset this line multiple times. NX has this easy option to offset lines, which we are going to use. I hope SpaceClaim also has this option, but actually I do not know where is that option, so I prefer NX. So we have selected the curve and the distance we are taking as 0.05 mm, that is 50 microns, and we are making 47 copies. We will not use symmetric offset because we are doing it for only one side. Let's add one more. So we are selecting this and let's see how much we need. So we need one more over here. So now our model is almost ready. We will finish the sketch, and NX has a tool known as divide face, which will create multiple surfaces on the top face. The edges of these surfaces are used by us to define the path for moving heat source. So we are selecting this sketch as the object and select OK. So now we can see multiple surfaces has been created. So now we will save this. And we will export this one as an IGS format. Now let's come back to Ansys. Here I am transferring this engineering data to my other model. We will select a new model which we just created on NX. So this is the one. It is good. It is a good practice to refresh the model section before using. So now we are in Ansys Mechanical, and as you can see we have a desired model over here. Now as you can see, the geometry is a single model, that is a single solid body, and in this one, the one that we made using space claim, let's see that once again. So as you can see, this model, this is not a single solid body. In the geometry section we can see that this is made up of multiple surfaces. So this is actually multiple surfaces instead of a single solid body. That's the reason why we are not using this model. Space claim is relatively new in Ansys, so I don't have much idea about space claim. Hence I use NX for my designing purposes. Here we will select stainless steel in the assignment section of materials. Now let's mesh this. Right click and select generate mesh. So the mesh is pretty fine, but we can get a better mesh by increasing the resolution. Go under sizing and in the resolution section increase it. Minimum is 2. 2 is default, 1 is minimum and 7 is maximum. It is a good practice to keep resolution less while testing, because increasing the resolution also increases the time taken by the model for simulation. So I am going to again reduce this. Maybe 3 would be better. Okay, looks fine to me. Initial temperature is set to 22 degrees, that is the room temperature. Now we are going to insert convection in the model. In the geometry, we are going to select all the faces. You can either hold the control key and click on all the faces, or just click and drag. All the faces would be selected automatically. In the film coefficient section, we are going to import temperature dependent, stagnant air, simplified phase. So the film coefficient is 5 e to the power minus 6. Now we are going to insert the moving heat flux. In the geometry, we have to select the faces on which the moving heat flux would flow. Ideally, we select all the faces on the top of the face. In the path section, we will select the path of the moving heat flux. This is the first line that we are selecting over here. Then we have to select the start point, that is the position from where the moving heat flux would start. We have to select a vertex for this, and that is the intersection of path with the edges of the model. After this comes the index, which would be 1 for the first one, second for the second one, and so on. First patch would be yes for the first one and no for others, whereas the last patch would be no for every one except the last one. We will come to this later. Now we are giving velocity and radius of the beam. Now for the source power intensity, the unit is watt per mm square. So our radius is 0.1. So the area of the beam. Okay, so this is the area of the beam. We will divide 40 watts with this area to get source power intensity. Okay, so we are going to use 1200. Now comes the start time and the end time. We need to keep into mind that time is always should be equal to distance by speed. First, let's calculate the distance. Here I am using nx for this. Calculating distance is easier in spaceclaim than in nx. I'll show you how later in this video. So the distance is 4.36 mm. So now what we do is we open a Excel worksheet and write down all the distances over there. I have written them already. Now we will use this Excel workbook to calculate the start time and the end time. First, let us give index so that we can define that yes, this is the first one, then the second beam, and so on. So first we will calculate the time taken by each beam. For this we are using the Excel formula as follows. It would be equal to the adjacent row by 9000. We will use the same formula for all of them like this. Now let's calculate start time and end time. Start time would be for the first beam would be 0 and the end time would be the time taken by the first beam. So we are using the formula that the end time should be the time taken by the first beam plus the start time. And the start time for the second beam would be the end time of the first previous one. Now we will select this and drag it so that the same formula is applied for all of them. So now we have the start time and end time for first 21 beams. So this is one of the most tedious process of this project. This is a time taking process, so I recommend you to do this for 5 beams at a time. So now we have the start time and end time for all of the beams. Now we have to input these times manually one by one into the project. This is a time taking and a tedious job. So I recommend you to do this slowly for like 5 beams at a time, because a slight mistake in this would result in the project failure, that is the project would not simulate. Now we will copy this first two and paste it so that we have 4. Now we will copy the first 4 and then paste it, which would give us 8, and we will do this until we have all the beams. So geometry, first patch, last patch, velocity, radius of beam and source power intensity would be same for all of them. So I have copied it. The only things that are going to be different is the path, start point and start and end times respectively. So the last one would have last patch as yes and the first one would have first patch as yes. Apart from that, all the others would have them as no and no respectively. So I am not going to type all of this again. I have one of the model ready. Let me open that one. But first let me close this model. And before that, let us see how we can measure distance in space claim. So measuring distance in space claim is very straightforward. We have to go to the measure tab and select the measure icon. Now we just have to select the line that we want to measure, and space claim will give its length. So now let me open another project which I have simulated already. So in this project, as you can see, I have simulated everything, but sadly we didn't get the desired results. I will share this project file with you. You can find it in the link given in the description below. So here you can see how all the moving heat flux have different indexes, and the last one has last patch as yes. So for this one, I would recommend you, if you are doing it from scratch, that you first simulate the first 5. For that, select the fifth one and set the last patch to yes. Then select the sixth one, hold down the shift key and select the 48th one. Now right click and click on suppress. This would suppress all the other beams or the moving heat paths. Now we have only the first 5 paths and we will simulate that. Let's solve. Solving would take time. I have skipped the solving. Once solution is complete, we can see the simulation. So I think I made a mistake over here. We need to set the step and time to be a little greater than what was the last end time for the last beam. So now we are going to unsuppress all and see the results. As you can see, the end time for the 48th beam is 0.026 seconds. So we are in analysis settings, we are taking the step and time as 0.06, which is greater than that for the 48th one. Apart from this, we have to make no other changes to the analysis settings. Now we are going to solve. As I said earlier, this process takes time. It would depend on the configuration of your system. So now we have a result ready. As you can see, we didn't get the desired results. We can use hit and trial method by changing the analysis time. The analysis time decides how much time we are providing for the cooling of the body. As you can see here, till 0.03 seconds, the body was heated with moving heat source, after which it is cooling down. Now over here we can play around with these controls. We can increase or decrease the legend size and can modify the values of each and every legend. So basically this was all for this tutorial. If you have any other questions, you are free to ask. I will answer all of them to the best of my knowledge. Thank you.